Hi there, folks. This is the midterm review, and I am the amazing Mr. Jansen, so away we go. If we look at this first one, it asks us to write the equation of this line in slope-intercept form, and there's two ways that we can kind of approach this thing. We can either put it in point-slope form first, or we can find the slope and the y-intercept and go from there. So the first thing is it says we're parallel to this line, so our slope is going to be the same, so our slope is also going to be a 3. So parallel lines are the same slope. So now from here, option 1 is to do point slope form, which is y minus the y value, which gives us a y plus 2, equals m times x minus the x value. And that's point slope form. This is an equation of the line, but now if I want it in slope intercept, I have to distribute that 3. And then I have to subtract that 2 from each side. Okay, so that's option 1. And really, I think that's the easier of the two options. But a lot of us don't have point slope form memorized. So option 2 would be to use y equals mx plus b. So we start with y equals mx plus b. I plug in what I know, which is the slope. And the other thing I know is an x and a y value right here, a 1 for x and a negative 2 for y. And now I can solve this thing for b. And so I subtract the 3 from each side. And I get b equals a negative 5. And then from there, just make sure you write the equation then, y equals a 3x minus 5. Okay. The next one, it asks us to write the equation in slope-intercept form. And this time we're perpendicular. So remember, for a perpendicular line, we have to do the opposite reciprocal. If this is a positive 1/2, our slope is going to be a negative 2/1, so a negative 2. All right. And then from there, we have our two options. We can either use point slope form. So y minus the y value equals m times x minus the x value. And again, that's minus a negative 4, so plus 4. And now it's distribute. Fix that guy up. So we distribute that negative 2. And then we have to add that 3 to each side. Okay. The other option is to do y equals mx plus b. Again, we plug in the things that we know. We know the slope. We know the x value is a negative 4. We know the y value is a 3. And I just skipped the actual y equals mx plus b part. But then we subtract the 8. And again, we get the same answer. I think that point slope form is a little bit less involved as long as you have point slope form memorized. So we get the same thing. Okay. If I look at the next one, it says to write the equation of the line in slope-intercept form that passes through these points. So again, same kind of deal here. We just have to find the slope. This time I have to do change y over change in x, where I do my slope formula, 10 minus the negative 2 over 4 minus the 1. So that's going to give me a 12 over a 3, which is 4. And then from here, you either use y equals mx plus b or use the point slope. I'm just going to do one of them this time. I'll just use point slope because, again, I think that's easier for most people. It doesn't matter which of these I choose. So y minus the y value, that's y plus 2, equals m times x minus the x value. And now just rewrite it. I have to distribute that 4 and then subtract the 2 from each side. And again, I think that's the easier method, but most of us have slope-intercept form memorized, so y equals mx plus b. Not all of us necessarily have point slope form, so we might have to go the other route. Okay. This one, it says find the x and the y intercepts. Remember, to find the x-intercept, you have to plug a 0 in for y. So if I plug a 0 in for y here, and most of the time we just solve this in our heads, but we can kind of see this is 4x equals 20. Divide each side by 4, so x equals 5. Okay. And really, we want to be able to kind of solve it in our heads because that's how we use this thing. So that's the ordered pair 5, 0. That's the x-intercept. And then the y-intercept, we plug a 0 in for x. And that's true for any function ever. Anytime I want the x-intercept, I plug a 0 in for y. Anytime I want the y-intercept, I plug a 0 in for x. Now I have negative 5, y equals 20. Divide each side by that negative 5, so I get y equals a negative 4. And I always write them as ordered pairs, 0, negative 4. And that's my y-intercept. Okay. The next couple here, we want to know if each of these is a function. And so when we have the graph, we do the vertical line test. When we're looking straight at ordered pairs, we're just looking for to make sure that every x value has exactly one y value. So we're looking for faithful x values. So when we look at something like number 5, we see that this -1 is repeated right here for an x value. And here the -1 has a value of 1. Here it has a value of 5. That one x value has 2 different y values, so it's not a function. This one, you just kind of have to think about the graph here. And really, as soon as I see absolute value, I know that this thing is a v. And typically we have this written as x plus 7 instead. But we can kind of see the vertex is -7, 0. That's back here somewhere. And it's a v that opens up. And just thinking about it real quickly, I notice I haven't been involved, I haven't done a real involved graph here, but vertical line test, it passes the vertical line test, so this one is a function. I'll just put yes. Okay. Next one, same kind of thing. We take a vertical line and drag it over the function, and really we're seeing if the vertical line touches one point at a time. So if we can kind of envision a vertical line being dragged across, there's no place where it touches more than one point, so this one is a function. And then this one, again, just thinking about a quick sketch of the graph, we know this thing is a parabola. We know it's got a vertex somewhere around, well, we could actually find the vertex. Not that the vertex is really even that important on this one. Opposite of b over 2a, that gives me a -3. And then you could plug it back in. That's a 9 minus 18 plus 2, so that's a -7. So we're looking at -3, -7, and it opens up. And really, even if I mess that up, all of these parabolas are going to look pretty much the same way. They're all going to be functions. The answer is yes here. They're all going to pass the vertical line test. Okay. The next one, this is the one that was supposed to have the asterisk on it. We should be able to do this without a calculator. Evaluate the expression y plus x squared plus 5zw, and we're just going to plug these guys in. So if I start plugging away here, inside the parentheses, I've got 6 plus x is a 5. And let's see here, z is a 7, and w is a 40. And really, for me, this comes down to 2 things: order of operations, and then understanding how you can mix some of those things up. So like this one, 6 plus 5 is an 11. I start inside the parentheses. I do that first. Let me save this multiplication for a second. And now next, in order of operations, I do the exponent. That's 121. Again, I'm saving this multiplication. Now I'm ready to do the multiplication. Here's where the second piece of this thing is, how can I shake up this multiplication? I don't have to do 5 times 7 times 40. I could do the 7 times the 40 and then times the 5. See, multiplication is commutative. And really, the easiest way to do this one, if we're thinking about mental math, save the 7 for last. If I do the 5 times the 40, well, that's an easy one. That's 200 because 5 times 4 is 20. Tack on another 0. And now when you think about this guy, that's another easy one because 2 times 7 is just a 14. So now it's 14 with 2 zeros. And now I can add this up. It's 1,521. Okay? So a lot of easy mental math things to do there. We just have to recognize, okay, I can do multiplication in any order. Okay? Next one, remember absolute value functions, we have to split them up. So this one I would do the 3x plus 6. The thing inside the absolute value could equal a 12. Or the 3x plus 6 could equal a -12. Okay? That's the nature of absolute value. A 12 versus a -12 will still give me the same thing when it comes out of the absolute value. And then I have to solve each of these. I'm going to do them simultaneously because I'm amazing. And then divide by the 6. Or sorry, divide by the 3. Okay, so I get these 2 answers. And really, with absolute value, we should plug those back in to make sure they work. This one, they do when you plug them back in. But watch out, you will get extraneous solutions every once in a while with those absolute value functions. Okay. The next one, this is a system of equations. We have to decide substitution or elimination. And when we look at this thing, everything's lined up. So we start thinking elimination. Then we look at those y's, they're already going to cancel out. So this is for sure, elimination is the best course of action here. So I add them up. And with elimination, we might have to multiply by something to get these things to cancel. This time we didn't. So let's say I get 5x equals a 10. And now I finish solving this thing, divide by the 5. And then once I have this x value, I'm not done. I have to plug it back in and get the y value. So here I get a 2. I just got to plug it back into one of these guys. Maybe I'll plug it into this one. Got 2 times 2 plus 3y equals 1. So that's 4 plus 3y equals 1. And then subtract the 4 and divide by that 3. Okay, and really most of the time we write our answer as an ordered pair for this one. All right. The next one's asked me to state the domain and range in interval notation. And so remember, domain, we just work our way left to right. So if I kind of start at the left side of this thing and say, okay, where does it start at the left and then how far to the right does it go? I can see that it starts right here at a -5. And I see that it keeps going until right here at a +5. So the domain is -5 to +5. And notice the function actually touches -5, so there's an equal to condition, so bracket. It actually equals the +5, so I use another bracket. And then doing the same thing, but going up and down this time. Let me get rid of those. If I work from and again, it's always least to greatest, so I look down here and say, okay, the bottom of it, it goes as low as -3, and the top of it goes as high as +3. So it goes from -3 to +3. And that's my range. And then I have to decide, okay, does it actually equal the -3? Yes, bracket. Does it actually equal the +3? Yes, bracket. Okay. This one just asks us to simplify, so we're simplifying this square root. So we just have to break this down to perfect squares, and for our purposes, -1 will be a perfect square. And then what's left is 15. Well, that's a 25 times 2. And now from here, I take the square root of each thing I can. Here, right here, the square root of -1 is an I. That's our imaginary number. The square root of 25 is a 5. So that's what goes on the outside. I can't really do anything with this 2, so it just stays under the square root. So I take the square root of everything I can, and I still have this 12 plus that. And that's it. Okay, we're just simplifying that radical. This one, we have to rationalize the denominator. Remember, we're not allowed to have any radicals in the denominator or any I values in the denominator. And when we have a binomial down there, we have to multiply by the conjugate. So I'm going to multiply this by 2 plus 5i. And whatever I do to the denominator, I have to do to the numerator. Okay? And so from here, it's just a matter of multiplying this out like in the numerator. I have to distribute that 4i, so that gives me an 8i plus 20i squared. Down here, I have to multiply this out. That gives me a 4 plus 10i. I'll actually multiply it all out. Minus 10i minus 25i squared. And then it's just a matter of simplifying. Like, remember, I squared is a -1. So that means I end up with an 8i minus 20 up here because of the -1. Down here, I end up with a 4. The 10i minus the 10i, those guys cancel out. But then again, I squared is a -1, so that becomes a plus 25. And so it ends up being this, 8i minus 20 over 29. And now the denominator is rationalized. I don't have any radicals left underneath there. Okay. This one, the negative comes out as an I. The square root of 81 is a 9. And there's nothing left under the radical, so that's it. Just 9i. Here, the problem that students typically have with this one is they start multiplying. We get excited when we see two binomials, but there's an addition sign here, okay? So I'm just going to add, I combine like terms. 2 plus 4 is a 6. Negative 3i plus 2i is a -1i. Done. All right. The next one is where we're actually multiplying. We have to FOIL or distribute, so we have to distribute that 2 to each of these. That's an 8 plus 4i. And then we have to distribute that -3i. That's a -12i minus 6i squared. And now we simplify. I can combine these like terms. That's a -8i in the middle. And then here I squared is a -1 again, so that gives me a plus 6. More combining of like terms. And that's it. 14 minus 8i. Done. This one says to solve by factoring. And so this guy, this is a difference of squares, and I factor a difference of squares into conjugates. It's an x plus 9 and an x minus 9. And then in the process solving by factoring, and I set each factor equal to 0. And I solve each. Here I subtract the 9 from each side. Here I'm going to add the 9 to each side. And so I end up with x equals a -9 and x equals a +9. And I can leave it like that, that's fine. Or if I want to, I could write it as x equals plus or minus 9, it's the same thing, okay? This one I'm going to go ahead and build a bridge. If I'm solving by factoring, I build a bridge, that gives me a -8. Two numbers that multiply to a -8 but add to a -7 will be a -8 and a +1. Since there's a 2 out front, I can't use my shortcut. I have to split up the middle term factor by grouping. So 2x squared minus 8x plus 1x minus 4. And now I group them. I group the first two together. I group the second two together. Out of the first group, I can factor out a 2x. That leaves me with an x minus 4. Out of the second group, remember with factoring by grouping, I have to factor something out. So I'm going to factor out a 1, which leaves me with an x minus 4. And so now my two factors are the 2x plus 1 and the x minus 4. And now from here, I have to set each of those equal to 0. So I do the 2x plus 1 equals 0. I do the x minus 4 equals 0. And I solve each. This one I subtract the 1. I'm not going to show every single step here. Divide by the 2. And that's a -1/2. Here I add the 4 over to the other side, so x equals 4. Okay? And those are my two answers. These next couple, it just says to solve each of them. It doesn't say by what method. It says make sure you use the quadratic formula for at least one of them. But like this first one isn't a good candidate for the quadratic formula because if you build a bridge, two numbers that multiply to a -10 but add to a -3 are a -5 and a +2. I can factor this one. And in fact, I can use my shortcut to factor this one, x minus 5 and an x plus 2, right to the two factors. And now I can set each of these equal to 0. Okay, so here I add the 5, here I subtract the 2. So that one would be kind of silly to use the quadratic formula. Now, would the quadratic formula work? Yes, but you have to make sure you simplify it all the way. Okay, this one, same kind of thing. I always check building a bridge first. I always want to see, can I factor this thing? That gives me a -12. The two numbers that multiply are going to be a +4 and a -3. So this one can be factored again. So that's the best method. I should solve by factoring. Once again, I can't use my shortcut on this one, so I'm going to split it up and factor by grouping. And here I'm going to factor a -1. And now I set each of these equal to 0. And from here, I mean, I'm sure all of you can solve these guys. That first one gives me an x equals 1. The second one, I subtract the 4 and divide by the 3, and I get a -4/3. So let me just leave those as fractions. Okay. The next one, you can try building a bridge, two numbers that multiply to a -8 but add to a +3, but spoiler alert, not going to happen. It's not going to work. So this is where we would want to use our quadratic formula. Opposite of b plus or minus the square root of b squared minus 4 times a times c. And remember, this is my a values here, my b values here, my c values here. The a value is a 1. And then that's all over 2 times a. And now it's just a matter of kind of just crunching the numbers and simplifying. Let's see, that's a 9. That's going to be a plus 32. So I get -3 plus or minus the square root of 41 all over 2. And that's it. That's all I can do with this one. I'll stop right there. Okay, and that's my x values. And if I was plotting these, yeah, I'd plug them into a calculator and I'd get some decimal approximations. Okay. The next one, same kind of thing. You start off maybe like building a bridge or something like that. So I go to build a bridge, and two numbers that multiply to a -5 but add to a +2, it's not going to happen, all right? So this one would be a great candidate for our quadratic formula, which is what most of you are going to do. And that's fine. Go ahead and practice that and simplify it all the way. I'm going to do completing the square. Remember, completing the square is a good alternative if the a value is 1 and the b value is even. So we create space. And now I fill in the blank. B divided by 2 and square it gives me a +1. Whatever I do to one side, I have to do to the other side. So now this guy factors into an x plus 1 squared equals a 6. And now I can take the square root of each side. Oops. Got a little carried away there. When I take the square root of each side, don't forget to do the plus or minus here. So that's plus or minus root 6, and I subtract the 1. And the quadratic formula will yield the same thing, but I will have to simplify it more, okay? And so that's the slight downside, but, you know, most of us just don't remember how to do or can do completing the square at this point, and that's okay. Don't bother. Do quadratic formula and just simplify, okay? The next couple says use the discriminant to determine the number and type of solutions here. So remember, the discriminant's the thing under the square root is the b squared minus 4ac. So here, b squared minus 4 times a times c. I just have to kind of look at the results of this. That's a 36, looks like minus 32, which is a 4. If the thing under the square root's a perfect square, I'm going to get 2 nice answers because I'll have plus or minus a 2. So this is 2 rational answers. Here, same kind of thing, b squared minus 4ac. So that's a 16 minus 16, which is 0. If the square root goes away, I'm basically not adding or subtracting anything, so I get 1 answer, so it's 1 rational. And really, this can be achieved by a little bit of memorization, okay? You get a positive that's a perfect square, 2 rational, 0, 1 rational. Here, b squared minus 4ac. That's a 9 minus 20, which is a negative 11. And so we get a negative under the square root. That's going to yield 2 complex. The discriminant is negative, 2 complex solutions. And then the only one that's not mentioned here is when you get two irrational answers. So 2 irrational is the guy that's missing. And we get that answer when we get a positive number that's not a perfect square. So something like, I don't know, 24 or 57, 92, okay? Any one of those would yield 2 irrational answers.